One, two, and three. Welcome everyone. Today you're gonna see about DAX formulas in action. So you're gonna see a little bit about Power Pivot. This is a sneak preview of what you're gonna see at the PASS Summit. Welcome to the 24 Hours of PASS. Your presenter is going to be Alberto Ferrari, who's a fantastic senior consultant for SQL BI. And introducing myself, I'm Joey D'Antoni. You'll hear me talking at the summit about hybrid BI and hybrid cloud and stuff. And I'll hand off to Alberto now. Next slide. Any technical assistance? If you require assistance during the session, type your issue into the question pane on the right-hand side of the menu. Maximize your screen, and you'll be able to see with Zoom the button on the top of the presentation window, and type your question. If you have any questions, by the way, type them into the question pane on the right side. Next slide. And we'd like to thank Microsoft. Microsoft does wonders with us with SQL PASS Summit and various other things we do, and then Dell Software, Spotlight, and all the other SQL Server things that we get from Dell. They do a fantastic job, and we couldn't present this to you without it. So with that, I'll hand off to Alberto Ferrari. Next slide. Oh, by the way, plan on attending the summit. It's early in the U.S., so it's 5 o'clock on the East Coast, 1 o'clock or 2 o'clock on the West Coast. So in the U.S., if you're up, it's going to be $1,895. Suddenly the euro has declined in the last month, so it'll be a little more expensive if you're in Europe. But it's the best SQL Server training you can get in the world within 3 days. And fantastic, like we see on the slide, over 5,000 attendees, 2,000 companies, 52 countries, 180 plus technical sessions. I'll be speaking a lot about hybrid cloud. Alberto will be speaking about DAX, and that's where I'm going to hand off. So go ahead, Alberto. Next slide. Alberto is a brilliant business intelligence consultant. His main interests are in methodological approach to BI, performance tuning VTL and SQL code, and he's an author and speaker at international conferences throughout Europe, Asia, and the rest of the North America. And I'll hand off to him now.
Okay, should I start now? I guess yes. So welcome everybody. Today we are going to speak about DAX formulas in actions. The goal of the session of today is to see what you can do with DAX. DAX is the new language of analysis services, but before starting with the slides, let me give you a few words about who am I, so you have an idea of who's speaking. I'm Alberto Ferrari, coming from Italy. I work as a consultant for SQL BI. I founded with Marco Russo SQLBI.com. We are business intelligence partner, that's as Maestro, MVP, MCP, and with a lot of different titles. But the real interaction about me is that I love doing business intelligence, and I always love to be on top of the technology. So that's the reason why we write books about analysis services, about DAX, about Power Pivot, about doing business intelligence with the Microsoft BI stack. And today I want to briefly introduce you to the DAX language. So let's spend a few words about what is DAX. DAX is a programming language. It's a new programming language that Microsoft developed with Power Pivot 2010 at the beginning, and then in SQL Server Analysis Services Tabular. Tabular is the new engine coming in SQL Server 2012 with the Microsoft BI stack. And it's a completely brand new language. So first of all, why did they decide to create a new language? We already have SQL, we already have MDX, there is the Excel formula language. There seem to be really no need to create a new language. Nevertheless, they did it because it was really important and needed. Tabular is a new engine. Tabular works with the Vertipack engine, which is a columnar in-memory database, completely different from previous engines. And so that's the reason why they decided to create a completely new language, which is designed to be optimized for building BI solution on Analysis Services Tabular. DAX is a strange language. It mixes together concepts coming from SQL, from MDX, from the Excel formula language. They are all mixed together. So at the beginning, when you start looking at DAX code, you will probably think that you understand what you are seeing because you use your previous knowledge about SQL or about MDX if you have it, or about Excel formula language. To some extent, this is correct because the roots of the language are in those previous languages, but DAX has new theoretical concepts, a new way of expressing formulas that make it very hard if you stop only at that point. In order to understand it correctly, you will need to clear your mind and start learning it as a brand new language. The core of the DAX language is that it's based on the Vertipack engine. Vertipack is the new engine which exists in Analysis Services Tabular and in Power Pivot. It's an in-memory database and it is a columnar database. Because of that, DAX has an incredible speed in computing values, but in order to make it efficient and in order to express formulas in the correct way, you need to understand very well how the Vertipack engine works. What are the main features, or if you prefer, the main characteristics of DAX? DAX is designed to be simple, and it is. It's a very simple language. It's not based on complex syntax. If you have any previous knowledge about MDX, you know that MDX is far from being simple. MDX is a very complex language, while DAX is very simple. Once you understand the theoretical foundation of the DAX language, everything else is very simple. It's powerful. It's incredibly fast. You will be able to compute values over hundreds of millions or even billions of rows without any problem about performance. It's amazingly fast if you use it in the right way. But simple doesn't mean easy. Simple means that the theoretical foundation is simple. Easy would mean that you could start writing DAX formulas in a matter of hours. This, unfortunately, is not true. In order to understand DAX and to write DAX expression in the right way, you will need to spend some time, I normally say a week or a month, learning the DAX language. Mastering DAX requires really some time. The agenda of today, so what I'm going to speak about today, is not that of teaching DAX. In order to teach DAX, as I told you, I would need to spend time giving you some theoretical foundation that is not, it's not feasible in 45 minutes. So I'm not going to teach DAX. Instead, what I want to do is raise your curiosity about the DAX language by showing you what DAX can do for you. And the idea of today is taking a workbook containing Power Pivot data about the Contoso database, and then starting doing analysis on that. Some analysis will be easy, and we will be able to do that by simply using Excel, plain Excel, without the need to learn a new language. But at some point, very early during the demos, we will need to start writing DAX code. And at that point, hopefully, you will understand, and I will be able to show you why DAX is needed and why they created this new language. So the goal of today is just doing a long demo by showing you what DAX can do for you. The steps will be the creation of basic calculated columns, then create some measures, then we will add time intelligence calculation to the report showing how numbers evolve over time, and computing some percentages. Then, if time permits, we will take the workbook we have created with Excel and transform it into a full analysis services database. And now it's demo time. This is the last slide. I'm not going to use slides during the course of the presentation. From now on, I will simply open Excel and start writing code. So let's close the slides. And let's start with a workbook. I have already created a workbook that contains some data. I have loaded data using the Power Pivot add-in for Excel, and I have loaded data from the Contoso database. The reason why I use Contoso is just because Contoso sells goods, so it's a good database to show what happens in a normal company that want to do business analysis, but it is much larger than AdventureWorks. And you can see in this data model we have the fact table containing sales, where we have date key, store key, product key, and a lot of different keys that point to dimensions. Then we have the fact sales that point to the store, and store point to geography. So we have a snowflake schema here. And finally, fact sales point to dim product subcategory, dim product category, and finally to dim date. As usual, we have a calendar table. When it comes to the volume of this model, all dimensions you can see are pretty small: geography, category, subcategory, while in the fact table we have 3 million rows, which is not a lot of rows, but it's already much more than you can expect to do analysis on with plain Excel. And I have already created a pivot table. That pivot table only contains sum of sales. As you can see, we have pivot table fields that contain all the dimension and all the attributes of the dimension, and in the values I have only put sales. Now let's start building a data model on top of it and do some kind of analysis. First of all, sales shown in this way doesn't mean a lot, so I need to take as usual, it never works when you start looking at things. Why I don't see dim date? Because everything is hidden, so I need to unhide from client tools these two columns and then go back to Excel. Now I have dim date. Okay, we can slice by year and then slice by month. You can see that slicing by year and month, I now see numbers divided by year and by month. The only problem is that, as you can easily see here, 2007 contains April, August, December, February. Data is shown in the correct way, but unfortunately it is not sorted correctly. And it is not sorted because by default Power Pivot and Analysis Services Tabular do sorting of attributes by using alphabetical sorting, and months do not sort alphabetically. So we will need to change the data model slightly in order to provide correct sorting. How do I do that? Well, in Power Pivot and in Tabular, each column can be sorted by using another column. So I can choose a sort by column on the calendar month label, and then choose another column in the model that might be useful to do the sorting. Unfortunately, in this data model, we don't have a column that contains the month number. We have dates, we have month labels, but we don't have a month number. Now, a solution would be that of changing the month number, adding 1, 2, 3, 4, 5 in front of it, but that would not be very professional and not very elegant. What we need to do is to add a new column to the calendar table that contains the month name. This column does not exist in the database, so we can create it. To create a column, we simply go to Add Column, and then we start writing some DAX code for the expression of the column. And in this case, the expression will be very simple. We want to write the month of the date. Now, what is this? This is a calculated column. A calculated column is computed during the process of the model, so it is computed when you refresh the data, and it is stored in the data model in the database of Tabular. It's completely different from calculations that you can do in views in SQL, because any kind of calculation in SQL, for example, happens at query time, while calculated columns exist and they are computed when the data model is processed. Of course, we don't like a calculated column as a name, so we rename it month number. And once we have the new column month number, we can go to the calendar month label, use sort by column, and now we have month number as one of the columns in our data model. Once we do that, we can go back to our pivot table, and now you see that 2007 contains January, February, March, April, May, June, and so on. So this is a first very simple example of what you can do with DAX. DAX gives you the option of creating calculated columns. Calculated columns are computed at process time. Now, the first time I saw this feature, I thought that Microsoft went completely crazy, and I wondered why they needed to compute and use memory, so store information in the database for one calculation that they could do at query time. Because, of course, you can imagine that because the calculated column is computed at process time, it uses space in the database. After a few months of using DAX, now I believe that calculated columns are probably the most important feature which is available in Tabular, because they give you really incredible power when used in the correct way. Now, for the calendar is fine. Since we are going to use year, month, and date a lot of time during our analysis, we can create a hierarchy. We can create a hierarchy, okay, on dim date by clicking on year, then month, and then full date, right-click, and create a hierarchy. We create a hierarchy as calendar. And the reason to create a hierarchy is because we can do analysis in a much simpler way. We remove year and month, and in dim date, we now have our calendar hierarchy that shows immediately both the year, and then under the year, the sales for each month, and under each month, each day of the month. Okay. Joy, maybe you are writing something. You can mute your microphone in the meantime. Thanks. Now, creating hierarchy is very useful because it makes all the analysis much, much simpler. We can do the same for the product. On the product, we might want to create a hierarchy that contains, for example, category, then subcategory, and finally, dim product. In order to create this hierarchy, we should start selecting columns from the dim product that contains category and subcategory. Unfortunately, you cannot create a hierarchy if a column does not belong to a table. So there seems to be no easy way to create a hierarchy based on subcategory and subcategory in the dim product table. But again, in order to solve the problem, calculated columns come very handy. We can go back to Data View, go to dim product, and we can add new columns to the dim product table by writing a slightly more complex expression, which in this case uses the related function. Related lets you compute a column in a table by using values coming from other tables which have a relationship with the current table. So if we write a related dim product category product category name, the result will be the category name of each product. And the good point is that now this is a column in the dim product table, which we can call category. We do the same operation for the subcategory, and we use related dim product subcategory name. And we call, of course, we rename this column subcategory. Now that we have category, subcategory, and product name in the dim product table, we can simply create our hierarchy. So we select category, then subcategory, and finally the product name, right-click, create the hierarchy, and now this can be easily done. And we call category, subcategory, the hierarchy. At this point, of course, we can hide these tables from the data model because they are no longer needed. Their content is completely moved in the dim product table. So I can hide from client tools dim product subcategory and hide from client tools dim product category. If I now go to my Excel workbook, I can remove calendar from the table, and in dim product I have the category subcategory hierarchy that shows the data as it is needed. Now this is another example of how a calculated column can be helpful. By using a calculated column you can denormalize data and move data here and there in order to show different normalize or denormalize your data model. So one of the important points of tabular is that by using DAX you can change the content of your data model, shaping it to fit your needs without the need to revert to ETL to do that. You do not need to modify SQL views or do any kind of operation on the SQL database. If you want some column, you can simply add it as soon as you need it. Now, these are calculated columns. In DAX, there is another kind of calculation that you can add, which is not based on calculated columns. Now we have sales divided by category and subcategory. Let me remove this field and put again dim date calendar. So we have sales divided by time. And this is the amount sold each month in 2008, for example. There are some kind of calculations that cannot be expressed as calculated columns and for which you need to use a different kind of calculations. These are known as measures or calculated fields. I still prefer to use the name measures. Measures are calculations which do not happen as calculated columns row by row, but instead they are computed at the pivot table level, so at the grand total level. One example of this kind of calculation is the distinct count. Imagine that I don't want only to know the number of products that were the amount of sales, but I want to know the number of distinct products that were sold for each month. This is a distinct count that cannot be computed row by row because, of course, for each single row the distinct count is 1, but if I want to do the aggregation using distinct count, I cannot compute it row by row. And in this case, what I will need is a measure. Let's switch back to data view. We can go to dim product and create a measure. To create a measure, instead of clicking on the columns of the table, you click in the measure grid, which is the area here below, and you start writing DAX code. We can compute the number of sold products equal to distinct count of fact sales product key. This will compute the number of distinct product keys that happens to be in the fact table. We know that at the grand total is 2516, which has formatted removing decimal points. And then we can go back to our pivot table, and in dim product we have number of sold products. If I click on it, you see that I now have the distinct count. So I know that in January 2008 I sold nearly 1959 distinct products. That is nice. But This kind of calculation is something that you can easily compute by using Excel. So you don't need DAX to compute simple distance count. DAX comes handy when you start doing a slightly more complex analysis. Imagine, for example, that we want to do an analysis about how many distinct products were sold compared to the number of products that we were able to sell. So we had a catalog of products that we could sell, and we want to understand how many we sold out of them. That is not hard to do, because if I want to compute the number of available products, I can go here and write a simple measure, which is available products. And to do that, I can create a measure that counts the number of products. I do a count rows of dim products, so I count the number of rows in the dim product table. I format it as a number without decimal places. You see that we have 251 distinct products in the product table. If we go back to Excel, now in dim product we have available products. Problem is, when I click on it, you see that the number is the same for all the periods. Why that? Because if I simply count the number of products in my model, I have all of them, and they seem to be all available at the same time. The number is not correct. And it is not correct because if you look back at the dim product table, in the dim product table we have a column available for sale date that tells me when this product was made available for sale. So it is not true that a product was always available. For example, this one, let's say Contoso 4 GB MP3 player, was available since 16 April 2007. So it should not be counted before that time. If you want to compute the number of available products, computing only the ones that were available at that specific date, you need to write the expression in a slightly different way. And this is one of the scenarios where Excel alone is no longer helpful, because to do this kind of calculations, you cannot simply rely on Excel. You need to write some more complex DAX code. So we want to change available products, and instead of doing a simple count rows of product, we start writing slightly more complex DAX. We calculate the number of products, but we don't want to count all of the products. We want to filter them. So we filter dim product, showing only the products where dim product available for sale date is less or equal than the last visible date. Dim date key. What we are doing here is we are computing the number of products which were available before a specific date. If we change the expression in this way and we go back to Excel, you now see that the number here are changing. And they are changing because in 2005 we only have 617 products. Then we increase the number of products, then we increase it again, and the number is changing. Now, looking at numbers, you immediately see that they are strange. It seems that I have sold more products, for example, in 2007 than I had available. I sold 1827 products and I had only 1816 products available. That looks definitely strange, as if there is some problem in my data. Or said in other words, I simply don't trust this report because numbers do not have a clear meaning. how do I know what went wrong? So what's wrong with my data? Clearly, it seems that I have sold some products before they were really available. So in order to look at the data, I can either browse through all my fact table here, searching for products that were available, that were sold before their available date, but that would be a time-consuming operation because I have 3 million of rows. Otherwise, I need to go to SQL, ask help to somebody to search for wrong data, or I can do a different operation. I can go to dim product, and I can check if there is something wrong. So I can create a new calculated column in the dim product table, and I simply check if the column available for sale date is greater than the minimum sale for this product. I calculate the mean of fact sales date key. This expression will contain a Boolean value, true or false. True if the product was sold before its availability. False if it was not. I can simply create my column. I rename it as wrong sale. And then I can start filtering it. You see that we have both true and false. I select only true rows, and I immediately see the products that were sold too early. They are all laptops, laptops. So there is somebody that is selling laptops before they are available, which is a common practice in selling computers. But the interesting part of this is that by using a simple calculated column, we can easily see what's wrong in our data. So we can identify the rows, and since we have this wrong sale flag, we can use it in the pivot table, for example, by going to dim product, taking wrong sale, add it as a slicer, and then show me only the sales that are wrong, and I immediately see the period where this happened, the products, and the dates where this happened. Now, at this point, I only need to go fix my database, correct it, and make it work in the correct way. Again, this is one of the scenarios where doing a BI and doing analysis, starting doing analysis makes it it is very easy to do this kind of analysis if you know DAX and you know how to use calculated columns. Now, we know where the problem is, and we don't want to spend time looking at these problems. The goal here was only showing you what you can do simply with DAX. Now we have number of sold products. We have available products, 2007, 2008. Imagine that we want to do another kind of analysis. What we want to do is adding some time intelligence calculations. So we have sales in the current year, and we want to add another calculation that shows me the sales in the previous year and then the growth in percentage against the previous year. This is pretty easy to compute because we only need to do some time intelligence calculation. So we go to the fact sales table. Here I already have created a measure which we used through the demo that contains the sum of the sales amount, so the total sale. If we want to compute the sales of the previous year, we can simply write a new measure, which is previous year sales, that computes the amount of sales, but instead of computing it for the current period, it computes it in a different period, in same period last year, based on dim date key. Once we have it, we format it correctly. Now we have previous year sales, and in our pivot table, in fact sales, we have previous year sales. We put it, and you see that in 2008, January, previous year sales shows a different number, which is the sales of 2007. So sales in 2007 is 269, and it is reported as previous year sales in 2008. The useful part of this value is now I have two measures. Having two measures, I can show in the same report sales and sales of the previous year on the same report. But our goal was not just that of showing the sales of the previous year. We want to understand the growth in percentage against the previous year. So we need to create another measure, and that measure will be computed as the percentage growth. We call it the growth percentage, which is the division between let me see, yes. Now, let me create the growth as previous year sales minus previous year sales. So we have a measure called growth that we can simply show, and shows the growth as a number. It only needs to be formatted in the correct way. So now it shows the growth in percentage. It's nearly always negative, so it seems like 2008 was not a very good year. And if we want to compute it as a percentage, we simply write growth in percentage equal the division of growth divided by previous year sales. Previous year sales. You see that the expressions, if you write DAX in the correct way and if you divide your formulas into smaller pieces, are very simple to compute. Growth percentage is this division. We format it as a percentage because we know it's a percentage. And if we go back to Excel, in fact sales, now we have growth in percentage. That shows the percentage of growth. Now, the problem of percentage of growth is that it is visible for too many rows. For example, you see that in 2007, growth percentage is blank, and that is correct because previous sales are not present, so there is no growth to be shown. But we see growth in percentage as 100% even in 2010, even if we do not have data for 2010. The data for Contoso stops in December 2009. The reason why we see this number is because if we divide growth by previous year sales, we always show a number, even if this number makes no sense at all. What we want to do is get rid of this minus 100%, which makes no sense at all. So to do that, we need to rely again on DAX and say, okay, you can compute this division, but please show the value only if sales has a value to show. So we can change this expression and say if the amount of sales is greater than 0, then show this division. Otherwise, show a blank value. Once you write it in this way, now the formula is protected by the if statement that checks if there are sales, then show the percentage of growth. If there are no sales, then simply hide the percentage and don't show anything. And now you see that the percentage is gone. If you want to create the report in the correct way, you simply remove all the values that are not blanked, and now you see data in 2009 and you no longer see data for 2010. So again, this is a simple example of what you can compute by using DAX and the way you can enrich your reports by using the DAX language. Now, it is this report, of course, looks nice, and it is easy to do analysis if we are at the grand total level. But as soon as you do some kind of more complex analysis, so for example, you can add a slicer for region country, select one country, you see that all these numbers are completely different. So in Australia, the sales are positive, even if at the grand total the sales are negative. Imagine that you want to understand whether a month was a good one or a bad one. In order to do that, you need to compare this month with something else. And comparing the value with a fixed value doesn't make a lot of sense because, of course, in different countries, the numbers are so different that doing comparison makes no sense at all. In Canada, all the numbers are negative, and in Bhutan, all the numbers are positive. So if you want to understand whether June was a good month or not, you cannot check only its percentage of growth. It would be much more fair to compare the percentage of growth against the percentage of that year in the country or in whatever selection was made. So to compare it with a different number, you can rely again on the DAX language. You can create a new measure, which is the growth percentage over that year, which is calculate the growth percentage for all what was selected by the user in the pivot table and for the current year, dim date calendar year. Okay, this measure will compute the percentage of growth over that year for that selection. It's a percentage, so we can put it in our pivot table. And now you see that the percentage shows for each row the grand total. And when I change my selection, that percentage changes. Now I can use these two numbers and do the comparison. And to do that, I simply go there and transform the growth percentage into a KPI, where I say compare the growth percentage with the growth percentage over the year. If it is less than 80%, then show it as red. If it is greater than 120%, then it is red, and between 80% and 120% of that year, show it as yellow. You can click on OK, go to the pivot table again, we remove growth percentage of the year, and now we have our KPI, which we can simply show. We can put the status and the value. Now you see that this value, minus 44, is yellow for Denmark, and the same value becomes red for China, and the same value becomes red for Australia. But the numbers completely change, and they show you very clearly whether one single month was a good month or a bad month for that specific selection that was made by the user. And again, this is a kind of analysis that you can easily do if you use DAX, and it is nearly impossible to do with plain Excel or without using the DAX language. Now, let's go back to the formula.
Hi, Alberto.
The point of this expression.
Hi,
yes?
it's Elizabeth. We actually have a question from Samuel Jones just before you move on. He says, I notice all the DAX formulas are being entered on the same column. Does it have to be, or is that personal preference?
No, that's just thank you for the question. That's just personal preference. You can put the measures wherever you want. You can, I mean, there's no difference at all between taking these measures and bringing it here or there. A measure needs to belong to a table, so you put the measure into a table, but that's just for user interface, so for cosmetic purposes. The measure will be shown under the table where it is put, but you can move that measure wherever you want. The only point here is that the measure grid, this area, is right now the only place where you can write measures, and it's pretty convenient if you work just with simple Excel. The point of these DAX expressions is that they look very simple. Unfortunately, as I told you, they are pretty complex to understand exactly. So it takes some time to learn how to write DAX code in the correct way. Now, I don't know whether there are questions or not, so if I need to move to the slides and finish my presentation, or if I have time to move further and show some other demos.
We do have a couple of questions. How about we go through them now, and then if you have a little bit of time at the end, you can maybe touch on something else. But
that's fine.
All right. So first, a simple one. Will we be able to see a recording of the demo posted anywhere?
And I guess the answer is yes. The demo is being recorded, so all the session is being recorded, and it will be available on the PAS website. I don't know the exact address, but you will find information about it, I guess.
Okay, yes, it'll be posted at www.24hoursofpass.com. Great. Next question. Are there advantages in creating the category and subcategory calculated columns in the data model as opposed to create a view in the database with joins between product, subcategory, category, and import the view instead of the product table?
Okay. And the answer is no. There are no advantages at all. Moreover, there are disadvantages. Whenever you can, that's a general topic about DAX, whenever you can shape your model in advance, so you have access to the database and you can modify the data model in SQL, it is far better. The reason is pretty complex to explain, and it has to do with the internals of the engine and how data is compressed. But generally speaking, if shaping of the model can be done outside of DAX, then this is way better. With all that said, a lot of times this cannot be done because changing the data model, in this case the change was very, very simple. But if you think, for example, at the other column we computed on DIM product, that one, okay, wrong sale, that checks for each column, if for each product, if the available for sale date is greater than the minimum sale, well, adding this column in SQL would be very expensive because it needs to scan the fact table for each product or to build temporary data structures. And so this column is better designed inside DAX because it's computed in memory, it has a small number of distinct values, and it's the best way to store the column. While for simple normalization or denormalization of data or shaping of data, it is way better to do that in SQL instead of doing them in DAX. The point is having the option of doing it. So I think calculated columns are beautiful because they free you from the need to go back to SQL to do simple modification to the data model. And it's, again, beautiful for prototyping. If you are building a data model for a customer, you can do the data model with the customer, shaping the model with him. One thing that I normally forget to mention is that you can create the complete prototype of a model by using simple Excel. So if you are working with a customer, I don't know how many of the attendees are consultants, but I am a consultant and I'm used to work with a customer. Whenever I open Visual Studio, the customer looks at me and says, okay, I'll come back later because that's that's geeky matter, and I don't want to look at it. So if you need to use Visual Studio to build a prototype, you don't have your customer beside you. While if you can do everything with Excel, the feeling of the customer is I can understand it, I can see what's happening, I can learn by looking at you doing something. And so building the prototype is very, very simple. That's the reason I normally use Excel to do all the prototypes. And then when the prototype is finished, if I need to change the data model, I will take my time, my geeky time, write the correct queries, and shape the model in the correct way. Are there any other questions?
Okay, great. Yes. Next question. Does DAX have the capability of working with extended code within Excel, like macros or code written in VBA?
Okay, and unfortunately the answer is no. We have seen everything inside Excel, but DAX is the programming language of analysis services tabular, so it's not strictly tied to Excel. That means it's a programming language by its own, and as of today, it cannot be extended in any way. So there is no way to write a store procedure or custom code or anything else inside the DAX programming language. So what you have seen right now is just plain Excel, but you can do the very same operation using Visual Studio on analysis services, and analysis services has no knowledge about Excel, tables, and what happens in the Excel world. So to some extent, you can mix Excel and DAX together. There are capabilities which I don't have time to show right now, but you can take, for example, a table from a query to the data model, materialize it as an Excel table, then perform further calculations using plain Excel, and later take the table and push it back to the data model, creating very complex workbooks that solve complex scenarios. But this kind of mix is not available in the DAX language. It's an operation that you do in Excel. So Excel and DAX are two different engines. DAX is the language of analysis services. Excel has its own formula language. And even if they look similar, they are completely different and completely detached one from the other.
Okay, great. And one final more.
Are there any other questions?
Yeah, one more question. Which resources do you recommend to learn DAX? So books or blogs that you would suggest?
Okay. Can I do a bit of marketing here? No. Well, if you need to learn DAX, you have really a lot of options. You can come to my session from Zero to DAX at PASS Summit, which will be in November. There are workshops that we hold online, and we do. There are recorded workshops at SQL BI that you can look to learn DAX, and there are books. There are not many books about DAX. I would say that there are mainly two books for DAX. One is a Rob Colley book that shows DAX for Excel users, and one is mine and Marco book about Power Pivot and about the DAX language. As of today, maybe I'm doing too much marketing, but that's something true. I guess one of the best resources is the SQL BI website, because we spent a lot of time writing topics about DAX. We did not do many introductory topics, many introductory papers about DAX. So we mainly have a lot of articles about advanced DAX. And we teach DAX, so we do online workshops and we do recorded workshops there at SQL BI. The only warning that I normally say that, but it's important to highlight it once more. If you want to learn DAX, take your time to do it. It's not an easy language. It's simple, but it's not easy. So it will take some time before you really understand it well. I taught it many times, and I know that when you think you understood everything, well, it's time to stop and try to understand it a bit more. After a couple of months, when you use DAX, one day some lights turns on in your head, and at that point you really understand DAX, and from that point everything is very simple and easy to understand.
Great, thank you. We do have a few more questions, but I think given that we're wrapping up to the top of the hour, we'll send you the questions, Alberto, and perhaps you could post the answers on a blog or a forum for people to view.
Sorry, I didn't understand the question, if it was a question for me.
We're closing in on the end of the session here, so while there are a few more questions, perhaps you could answer them on a blog post or forum post.
Absolutely,
24
that
hours
is fine. And by the way, if you have any question, just don't hesitate to write me, and I'm normally happy to answer email about questions about DAX.
Great.
Okay. So, last few words about DAX. DAX is powerful. It's built on calculated columns, measures, and it's much, much more powerful than Excel alone. What we did is just scratching the surface to see what you can do with very simple DAX. If you take your time, you will really be able to move to the next level in data analysis and do analysis on really huge data model. I personally use DAX to do analysis over several billions of rows in the fact tables, and well, the speed really shines, and the kind of calculations you can do is really, really awesome. I don't know whether, oh, that was the question slide.
All right, thank you.
I will be presenting, oh, okay, you go on.
I was just going to say thank you very much, and yes, if you liked what you heard here, check Alberto out at PASS Summit 2014. He'll be doing a pre-conference session from Zero to DAX, as well as a general session, Advanced Modeling with Analysis Services Tabular. And don't forget to use the discount code 24HOP14 to save $200 on your registration.
Great. Thanks everybody for attending the sessions, and I really hope to see you at the PASS Summit in a couple of months from now. Thank you.
Great. Thank you very much, Alberto.
Okay.